So for the last part, for the OSPF advanced feature, we will introduce the passive interface, and then we will do some practice. Okay, so for the passive interface, actually, we know in OSPF network, we have to send the header packet to discover the neighbors and to build the neighbor relationship, use the OSPF hello packet. Of course, we have to use the hello packet to establish the neighbor relationship and to maintain the neighbor relationship, right? And elect the DRBDR device. So this is the hello packet. So for the OSPF network, we can see in this topology. And for R1 and R2, we have to send the hello packet between each other, right? But for the R2 device, actually, this interface is a gigabit 1. Actually, this interface connected with the terminal or the PC or our customer. So for the customer with our router, we don't need to build the neighbor relationship. Of course, we don't need to establish the neighbor relationship, and we don't need to mention the neighbor relationship between our router and endpoint. Okay. So now, if we don't want to waste the bandwidth on the link, or if we don't want to waste the resources of the routers, how to do? We can set the interface on the routers to become the passive interface. Okay, to become the passive interface. So here we can see for the gigabit 1, it's connected with the terminal, right? So for this interface, actually we can set this interface to become the passive interface. So if we set this interface to become the passive interface, what happened? Actually, if we configure this interface to become the passive interface, and we will find for this interface no longer sends the hello packet. Okay. And for this interface, because it's connected with the PC or the terminal, actually, we set this interface to become the passive interface. It will save the bandwidth between the R2 and the terminal. Of course, it also can save the resources for the R2 to send the hello packet to the PC. So this is why we can set the passive interface on gigabit 1. So how to configure the passive interface? Here we can see first we enter into the OSPF process, okay, and then we use this command passive interface, and for the interface number gigabit 1. Okay, this command is very easy, and we use this command to do the configuration. And after we configure this command on the routers, so for the link information, actually, we also can send it to the neighbors. It won't affect the link information to the neighbors. Okay, so actually the passive interface is a good choice for you to optimize the resources of our router, to optimize the bandwidth of our router. Okay, so for the next page. Okay, for this example, actually we can see here is a aggregation switch, right? And we add this interface and this interface into the OSPF, right? So after we configure all the interface into the OSPF, so every interface will receive much hello packets, right? So for the switch, actually, for the 3 switch, we don't want this 3 switch receive the hello packet from the aggregation switch. Actually, we can set this interface, this interface, this interface, this interface to be the passive interface, right? So here we can say the configuration, and we end into the OSPF process and use the passive interface default. It means we will set all the interface to become the passive interface by the default. But actually, we don't want to set the gigabit 024 this interface, because this interface connected to the high layer device. So we need to build the neighbor relationship. We need to exchange the information between each other and have to receive the hello packet, right? So we add the no passive interface gigabit 24 just for one interface. We don't set this interface to become the passive interface. Okay, and then after we finish the configuration on the device, and for this switch, so don't need to receive the hello packet from the aggregation switch. Okay, so this is a passive interface, can help us to save the bandwidth resources, save the packet from other device. Okay, so now let's end into the practice question. Here is some practice question. Let's see together. Okay, so first is a multiple choice, and which of the following scenarios require a manually configured OSPF default route? So option A is router in the backbone area advertise the default route to the local area, and the option B is router in a common area advertise the default route to the local area, and the option C is router in a step area advertise the default route to the local area, and the last is the router in an SSA area advertise the default route to the local area. So what's the answer for this question? And we can say it's a ABD, right? It's ABD. Because actually, for the default route, we know an SSA area, we have to deliver the default route manually, but the step area don't need to deliver the default route, right? It's different. And for the common area and the backbone area, if we want to deliver the default route, we also have to configure or manually configure the OSPF default route. Okay, next practice question is a single choice. What function is implemented when the default information originate command is followed by the always parameter? So we know actually the always parameter is to deliver the default information whatever in the local we have or we don't have the default route, right? Okay, so for the option A, is deliver the default route regardless of whether the local routing table contains the default route. And the option B is the default route can be advertised to OSPF areas only when the local routing table contains other default routes. And the option C is this parameter is required in the command. So we can see for this question, the option A is the answer, right? Okay. So next practice question is which devices can be configured with the router summarization feature? So the option A is ABR in the area where routes are generated. And option B is ASBR in the area where routes are imported. And option C is any ABR. Option D is any ASBR. So here, which answers we will choose? Okay, the answer is AB, right? Okay, and we have to do the summarization on ABR for inter-area, right? And of course, we also can do the summarization on ASBR for the external routes. Okay. So of course, we also introduce some scenarios about the summarization, like the NSSA area, right? So if in the NSSA area, we have to do the summarization on the ABR device, which belongs to the NSSA area, right? Okay. So next practice question is, which of the following statements about OSPF virtual link are correct? So option A is virtual link can resolve the problem that area 0 is valid. And option B is virtual link can solve the problem that a common area is not connected to the backbone area. And option C is the IP address in the virtual link configuration command is the physical IP address of the remote device. And the option D is the area ID in the virtual link configuration command is the ID of the area to be traversed. So for this question, and the answer is what? Okay, so the answer is the ABD, right? So the virtual link actually can solve the problem that the area 0 is valid, because we have to follow the rules in one OSPF process. There is only one area 0, right? Okay. And the virtual link also can solve the problem that a common area. It means the non-backbone area is not connected to the backbone area. Because in the OSPF process, we have to keep every common area have to connect it with backbone area directly. Okay. And for the C option, actually, is wrong, right? Because the remote information can be the local interface, right? Can be the local interface. So for the D, the area ID is the area to be traversed. Okay. So if we traverse the area information is 1, and we save the area ID to be the 1. Okay. And next question is, what of the following statements about OSPF authentication is incorrect? Option A, OSPF simple password indicates that the password is visible in the device configuration. And option B, OSPF cryptographic authentication on Ruijie devices support MD5 or SHA authentication. And option C, when OSPF area authentication is enabled, all devices connecting to this area must be authenticated. So for this question, the answer is C, right? The answer is C. Okay, so next. And after an OSPF interface is configured as a passive interface, which of the following statements is correct? Option A is the interface cannot send hello packets. Okay. And option B is the interface cannot receive hello packets. And option C, the interface cannot send or receive hello packets. And we can see the answer is A. Okay. So now let's overview the OSPF protocol for the summary. And the first summary is actually about the advertised default route. So for the OSPF area, actually only the sub area can automatically deliver default routes, right? And when we deliver the default routes, actually we have two ways, right? And the first is the default information originate, and second, we can add the parameter is always parameter. Is the default information originate always. So the differences between two is actually if we use the default information originate. So we have to make sure in local we have the default route, and then we can use this command. So now, if we use the default information underneath always this command, so regardless for the local device we have or we don't have the default route, we can deliver the default route. Okay, but actually be careful, use this command. Maybe sometimes will cause the problems, like the routers can't access to the external network, because for the deliver the default route always, and it means maybe for the local device don't have the routing entries to access the external network. Okay, so for the default information underneath always this command, if you use this command, and be careful. Okay, and for the deliver the default routes, actually we also can add the cost information. Okay, and to modify the cost value, of course we also can modify the cost tab, like the tab 1 or tab 2, so it will choose like the OE1 or OE2 or ON1 or ON2, okay, in our routing tables. And the next is the OSPF summarization, and we know the OSPF summarization can minimize the number of the routing entries in the network. Actually, we can decrease many routing entries with just one routing entry, right? So if we use the OSPF summarization, these advanced features actually can help our device work better. Of course, can decrease the routing entries number. Of course, can help the engineer manage and configure our network easily. Okay, so for the summarization, we configure the command on ABR or ASBR device. So for the ABR device, actually, we just can summarize the routes in the local area. It means for the inter-area routing information, we can do the summarization on ABR device. And another situation is to do the summarization on ASBR device, right? And for ASBR device, actually we know we will do the redistribution on ASBR and then import the external routing information into OSPF domain. And after this, we can do the summarization on ASBR device. While for another scenario, actually, is an NSSA area. We can do the summarization on ABR device, which belongs to the NSSA area. Okay. So the next is a virtual link. For the virtual link, actually, we know it's a solution to solve the problem that the area 0 is valid, or the problem that connection to area 0 fails. Maybe the non-backbone area is not connected with area 0 directly. So now we need to configure the virtual link between the routers. Okay. And next is the authentication. And here we know for the authentication, we have two methods. Is in the interface authentication, and second is the area authentication. And for different methods, and we have encryption modes. It's a simple password and the cryptographic authentication. Okay. And for different tabs, for the different method, we have to keep the parameter to be the same on two routers. For the neighbor relationship between two routers, if we set the authentication tab on one router, so for another router, we have to keep the parameter to be the same. And if we set the password information on one router, and for another router, we have to keep the password parameter to be the same. Okay, so this is the virtual link authentication. Okay, And for the virtual link authentication, actually, we have to pay more attention about the area information, okay, the area ID. And if we do the authentication on area 0, and for the area which the virtual link through, we also have to configure the authentication. And the last advanced feature is the passive interface. So the command is very simple, right? And we use the passive interfaces command to optimize the OSPF hello packet sending over the links. So actually it can help the device work better and to save the bandwidth, don't need to send the user's hello packet. Okay, so this advanced feature actually can help OSPF work better and to support for more different scenarios. Okay, so the class is about the OSPF advanced feature is this. So that's all. Thank you.